In this series of videos, I'm going to look at the answers to the F325 June 13 paper. So the first question is a question on lattice enthalpy and Born-Haber cycles. So it starts with the definition for lattice enthalpy. So that's the enthalpy change when 1 mole of an ionic lattice is formed from gaseous ions. The next part of the question, we're given a partially completed Born-Haber cycle and we've got to fill in the rest. So it's these two empty boxes here. And you'll notice the first thing I've done is I've actually written on the side there what these steps indicate. So you can see that this is the enthalpy change of formation for calcium oxide. And then we need to atomize the calcium. We need to atomize the oxygen. It's then the first ionization energy of calcium. Then it would be the second ionization energy of calcium. So the answer to this box is going to be the calcium 1 plus gas needs to change into calcium 2 plus gas. Remember, you're only allowed to change one thing at a time. So there's your change. So the O gas stays the same. But because you've removed that second electron, you need 2 electrons here. So if you think about lattice enthalpy, what you've got to have are gaseous ions here to create the lattice. So we've got the calcium 2 plus ion in the gaseous form. So we need to sort this oxygen out now. So then the first thing we're going to do is do the first electron affinity of oxygen. And that's going to take the O gas to O minus gas. So that's done by adding one of those electrons to that. So you've only got 1 electron left on here. And then the final thing is to add these two, combine these two things together. So what's going to live on this line must be the calcium 2 plus gas ion and the O2 minus gas ion. So that's step G, is the second electron affinity. And that hasn't been a waste of time here because the question goes on and asks us about some of these steps. There it is there. Name those steps. So step A, C and G. So let's go back to the cycle. So A is the enthalpy change of formation of calcium oxide. C is the atomization of oxygen. So look at what's changing. And G, O minus gas to O2 minus gas. So that is the second electron affinity of oxygen. And the calculation starts now. Calculate the lattice enthalpy of calcium oxide. So we're going to use Hess's law now. So I've got two colours here. I've got the sort of orangey colour and green colour. So essentially my roots both start at the elements and they both finish at the lattice, calcium oxide lattice. So step A is one way of going from here to here. The other step, the green step, is all of the green steps added together. Okay, so there's the solution there. So the orange step is equal to the sum of all the green steps. There's the unknown. So basically we need to sort these numbers out, take them over to this side, change the sign, and you get minus 3454. Now, lattice enthalpies are always exothermic, so if you're not getting a negative number there, you've obviously done something wrong. The factors that affect the value of lattice enthalpies, there are two factors at play. There's the ionic radius and the ionic charge. So I'll just go through this. The ionic radius, the smaller the ionic radius or size, it's probably better to say radius. The smaller the ionic radius, the more exothermic the lattice enthalpy. And the ionic charge, the greater the ionic charge, the the more exothermic the lattice enthalpy. And then just combine those two things together. The smaller ion, the greater the charge, the greater the attraction, and therefore the more exothermic the lattice enthalpy is going to be. And I've just written up in quite large capitals there, it's all about ions. The most common thing I see when I'm marking these is atomic radius. We're not talking about atoms here, we're talking about ions.